The Institute of Atomic Molecular Sciences at academic Sinica is a multidisciplinary center of excellence in fundamental research. Our faculty members have background in physics, chemistry, and engineering, which creates a highly interactive environment. With advanced instrumentation and also an interdisciplinary approach, the research groups aim to solve important scientific problems that are of broader impact on other fields and perhaps of application potential.
And we had a dream at the time. We were hoping by the year 2000, by the turn of the century, Academia Sinica would become one of the well-known institutes in the world. So young people didn't have to go abroad, stay here to get good education, to get good research done. And to a certain extent, we have accomplished that.
Our members conduct innovative research in advanced materials and surface science, atomic physics and optical science, biophysics and bioanalytical technology, and also chemical dynamics and spectroscopy, in which we have an internationally renowned research group.
So AMO stands for Atomic, Molecular, and Optical Physics. And in general, it is an interface between atoms or molecules to the light. And then we use the interaction between atoms and the light to manipulate the system in the quantum regime. And as for ultra-cold atoms, they are at the temperatures from microkelvin down to nanokelvin region. And they are simple and can be precisely controlled. And we can use them to study fundamental physics and to emulate complicated models in condensed matter physics. And we can even create new type of interactions with designed properties, and that will lead to new forms of matter which have no counterparts in material systems.
In order to understand how a chemical reaction is taking place, we built a few sophisticated and unique molecular beam apparatuses. By measuring the mass, velocity, and the angular distribution of the reaction product, we can construct a picture of how atoms interact with each other in a chemical reaction. The photodissociation of chlorine peroxide is a bottleneck process in the ozone hole formation. We synthesize chlorine peroxide in a molecular beam and detect it with mass spectrometer. By focusing a laser on the molecular beam, we can quantify the process of how a chlorine peroxide molecule absorbs a photon and dissociate. This information is crucial to explain the ozone hole formation, a global problem of human beings. The success of this work and others heavily rely on the capability of the machine shop, the glass shop, and the electronic shop. With their help, we can do the experiment others cannot do.
AMSS is the acronym for Advanced Materials and Surface Sciences. Our goals are to incept new fabrication methods, characterization methods, and use materials with novel properties. We exploit the concept of constrained self-organization to fabricate nanostructures with atomic scale precisions. Atoms and molecules are allowed to self-organize into the desired nanostructures on a substrate which has a constraint defined by its nature, properties, or lithographic methods.
So I'm a Japanese working in Taiwan in the Institute of Atomic and Molecular Sciences, and I do theoretical research in trying to understand how you can use computers to simulate how atoms react when there's light and when there's no light. So one of the big points for coming to this institute was the world-class experimental researchers here, where I can go talk with them and learn the new science that they're doing in the experiment. And for a theorist, it's very important to know what experiments there are and what theory is needed in those experiments.
Our biophysics group focuses on biological instrumentation, especially in microscopy and spectroscopy. We have developed and used a broad spectrum of advanced techniques, including super-resolution microscopy, interferometric scattering microscopy, CARS, nanodiamond tracking, nanodisk-based NMR, and capillary isoelectric focusing for biological studies. Our microscopy and spectroscopy advances cover from atomic level all the way to live animal studies. One strength we have is we create a collaborative and synergistic environment for all PIs, including those not in the biophysics.
Our institute is also an active participant in the Taiwan International Graduate Program within Academic Sinica. The goal is to train the next generation scientists in molecular science and technology, and also in nanoscience and technology. This is an exciting place to do fundamental science. We have excellent colleagues, great facilities, and world-class research teams. The connection with National Taiwan University is certainly a big plus. The combination of a campus life and the research institution makes you feel that you are always young and energetic.